So this particular problem is about again the equation of the velocity as with respect to time is given, and then we have to find out basically the x coordinates and the distances in at some point of time or during a particular duration of time. So at the moment t equal to 0, that is at the when at the starting the particle leaves the origin and moves in the positive direction of the x-axis. So initially the particle is at the origin and it starts moving in the positive direction of the x-axis. The velocity varies with time as this particular thing. So velocity as time increases, the you can see the 1 minus t by tau. So the value of that becomes less and less as time increases, where v naught is the initial velocity vector whose modulus equals to this. Okay, so I've got these things. You need to find out the x coordinate of the particle at different moments of time. Moments of time in the particle is at distance 10 centimeter, distance 10 centimeter, which is important point, and the distance s covered by the particle during the first 4 and 8 seconds, and also draw the approximate plot s of t. Okay, so the first case, um, first of all v is this, right? Okay, so v is equal to v naught into 1 minus t by tau, right? Now, and we also know that at t equal to 0 it is at origin, right? Okay, so basically since it is at origin at t equal to 0, whatever displacement is with respect to t equal to 0 is basically the x coordinate, right? Because at t equal to 0 it is at the origin. So now if we just plot the magnitude v versus t, then obviously it is a linear, it will be a linear, I mean it will be a line with slope of this. You can write the magnitude v as magnitude of v naught minus v naught t by tau, right? This is what you have as the magnitude of the velocity. So initially at t equal to 0 it starts at a v naught and it keeps decreasing linearly. Okay, and the slope is equal to, very clearly it is minus v naught by tau. Okay, so this is basically the velocity versus time curve. Now we already know that your x coordinate, right, x coordinate is basically the displacement from t equal to 0. So x is equal to integral v dt from t equal to 0 to t equal to, let's say, t equal to t, right? So this becomes integral v naught minus v naught t by tau times dt from 0 to t, right? So if we integrate, it becomes v naught t minus v naught t square by 2 tau from 0 to t, and 0 it is 0 and t it is same. So v naught t minus v naught t square by 2 tau. Now if we take out v naught t, it becomes as common, v naught t as common, it becomes v naught t multiplied by, within brackets, 1 minus v naught t is taken out, t by 2 tau, right? So this is the expression for x, v naught t multiplied by 1 minus t by 2 tau, and you can substitute the different times and like 6, 10 and 20 seconds to get the x coordinates. Okay, Okay, so now for the second part, the moments of time when the particle is at distance 10 centimeter from the origin. So the distance is 10 centimeter from the origin. The x coordinate ends can be either 10 or minus 10. So basically we have found out from the first part the equation for the x coordinate, which is this particular equation. So they'll use that in order to solve the b part. So first case is so it is from the origin, of course. So distance 10 centimeters. So first is x equal to 10 and all the units are in distance units are in centimeter and time is in seconds. Okay, let's move on. First case x is equal to 10, so this means v naught t into 1 minus t by 2 tau is equal to 10. Now we need to substitute values of v naught and tau. V naught is 10, tau is 5, so it is 10, tau is 5, 2 5 is 10, 10 10 10 cancels out, which means okay, the t to 1 minus t by 10 equal to 1, right? And okay, so t, so if we multiply t inside and multiply both sides by basically 10, then 10 times t minus t square equal to 10. Okay, which means t square minus 10 t plus 10 equal to 0. Okay, which means t is equal to, so from the quadratic formula basically, minus b plus minus root over b square minus 4ac by 2a, 10 plus minus root over 60 by 2. So we can take out 2, 15 becomes 5 plus minus root 15. So what are the times then? One is t equal to 5 plus root 15, which is approximately, so root 15 is, you can say, of course it's approximately 4, so I'm just writing the approximate value for now. You can check the actual value. So it is approximately 9 seconds. T equal to my 5 minus root 15. So it is approximately 1 second. These are the approximate values. The actual value will be somewhere nearby. Acha, case 2 is when x is equal to minus 10. So okay, so we just need to substitute instead of 10 minus 10, which means 10. So basically the right hand side over here will become negative, 10t minus t square. So essentially 10t minus t square equal to minus 10. 10t minus t square equal to minus 10, which means t square minus 10t minus 10 equal to 0. T equal to b plus minus root over b square minus 4ac is already, there is a minus, so minus 4ac plus t divided by 2a, 10 plus minus root over 140 by 2a, 2, so becomes 5 plus minus root over 35. Now if you see, t has one root is 5 plus root 35, which is approximately 5 plus root 35 is approximately 11 seconds. The other root is 5 minus root 35. Now this is less than 0 because we know that 5 is root 25. So root 25 minus root 35 will be less than 0. So this is an invalid solution. So essentially we have these 3 times. One is 5 plus root 15, which is approximately 9 seconds. 5 minus root 15, which is approximately 1 second. The third is 5 plus root 35, which is 11 seconds. So intuitively, if you want to understand, you can say that and this is just extra. So this is the origin, right? So initially the point particle leaves the origin, moves in the positive direction of the x-axis, right? So initially, basically what happens is the particle is moving in this direction, comes to a halt somewhere, then starts moving back. So basically, and this distance happens to be greater than 10, right? That is why there are 3 time instances when it can be at a distance of 10 centimeter from the origin. One when going towards the positive x-axis, one when coming back, so there will be t1, t2, and one when going this way, is somewhere around here, which is t3. Okay, that is why you have 3 solutions for this. Fine. Alright, now consider the third part. Distance as covered by the particle during the first 4 and 8 seconds. Draw the approximate plot st. So if we can just find out the equation for s of t, that is sufficient. We can substitute the values of 4 and 8 in that. So here they represent, generally s represents displacement, but here they are representing it. Here they are basically denoting denoting s as the distance. So now for distance, as I have shown just now over here, so the particle goes till some s max, and then it retreats back towards the origin. So, and also if we consider basically this x coordinate versus time, which is this, it is again like a the shape will be that of a parabola with let's draw it first. So the two roots will be 0, t equal to 0 and t equal to 2 tau, right? So let's draw an approximate plot of x coordinate versus time, right? Initially the velocity has a velocity, positive velocity, which decreases to 0 and it drops down. I mean the velocity keeps increasing in the negative direction after that. So these are the two roots, 0 and 2 tau, right? And at some point, basically where the velocity is 0, it retreats. So when is the velocity 0? We can see from this equation. From this equation, the magnitude is 0 when t equal to tau. So this is t equal to tau. Velocity is 0, and we can substitute t equal to tau in the distance equation, in the x coordinate equation. Sorry, if we substitute tau here, tau cancels, 1 minus half is half, and it becomes v naught tau by 2. So v naught, this is v naught tau by 2. You just need to substitute tau in the equation for the x coordinate. That gives you the maximum x coordinate. Okay, so now if we are to plot, if okay, let's not plot, let's directly write down now. So till tau, the distance is equal to the displacement. After tau, what is happening? The distance covered is equal to, so if you can just again, so O, this is the S max, this is, let's say, S max, right, which we have found out just now is V naught tau by 2. So at t less than tau, the particle is somewhere between O and, let's say, this A, O and A. So there the distance is equal to the displacement. But after t equal to tau, the particle retreats. So it will be somewhere on the left of A, of course, and going towards the negative x direction, right? Now the distance covered would be S max plus, let's say the point is B, plus this AB. Okay, that would be the distance covered, or we can also say that it would be, so basically this is the x coordinate, right? Okay, and okay, so basically what is happening is the distance will be S max plus this AB, right? After t, when t is greater than tau, I'll write it separately. When t is less than, okay, or equal to tau, here S is equal to x. When t becomes greater than tau, S is equal to whatever is your S max, okay, S max, right, plus basically we can take this as AB, right? So B is basically wherever the particle is at that point, the x coordinate, the distance between the x coordinate of S max and the particle's x coordinate. Okay, so S max plus AB is basically the distance. Now what is AB? Sorry. So what is AB? AB is nothing but S max minus OB. OB is x. So this becomes 2S max minus x. So now if we substitute the values of x from the equation that we already got in the first part, v naught into t into 1 minus t by tau. So when t is less than tau, s is equal to v naught into t into 1 minus t by, just verify, t by 2 tau. And when t is greater than tau, becomes 2. What is S max? S max is v naught tau by 2. X v naught so basically this is the distance as a function of time, so represented by, it's basically conditional on whether t is less than equal to tau or t is greater than tau. So it is less than equal to tau, it is v naught into t into 1 minus t by 2 tau. When t is greater than tau, it is v naught tau minus v naught t into 1 minus t by 2 tau, right? So you can substitute the values of the time in order to get the values for the distance covered. Thank you.